Good morning. Today we're going to finish up Unit 5 and talk about how to write linear equations to model real-world applications. First, we're going to talk about slope-intercept form, and we are going to find the y-intercept, which is the initial point or starting amount, and then our slope, which is our rate of change when we're doing this. So we're going to do the same thing that we did in 5.4 and write the equation of the line by finding our m and our b. So I'm going to start with my b. My b is at 0. And then if I find where it crosses at the corner, I can draw a triangle in. And notice my labels, I go up 50 over 2. So I go up 50 over 2, which reduces to give me 25. So my equation is y equals 25x, or y equals 25x plus 0. Okay, in this problem, the meaning of the y-intercept is that we start at 0 hours with 0 miles traveled. Okay, the meaning of the slope is that every 25 miles takes us an hour. Okay, so we are traveling at 25 miles per hour, or 25 miles each hour. Either one of those would be the same thing. Okay, next problem. A cab ride in San Francisco costs $8 for the first 5 miles, and then the fee increases $2 for every additional mile. Write and graph the equation that models the total cab fare. I want you to think about this. We have to be really careful because we're not starting at $8 and then adding 2 for every mile afterwards. We are actually having 5 miles for $8 total, and then we are increasing by $2 every mile. So what that's going to look like is we're going to go 5 miles for $8, so I'm actually starting at this point here. And then I'm going to go up to, look at your scales, over 1 after that. So here are my points from there. To write the equation, I'm going to use point-slope form, which is y minus y1 equals m times x minus x1. So when I plug that in, I get y minus 8 equals 2 times x minus 5. And I can actually solve to put this in slope-intercept form. So if I distribute, I get 2x minus 10. And then if I add 8 to both sides, we get y equals 2x minus 2. Well, notice that minus 2 doesn't actually fit on the graph. And I'm going to show you how I would actually graph this, and it's kind of different than what you're thinking. No matter what, I'm going to pay $5. So if I go 0 miles, if I go 1 mile, or if I go 5 miles, I'm automatically going to pay that $5. And then after that, we add $2 to each one. So I'm going to start at this point and go on from there. And that's just a special case here because no matter what, it's $8 for the first however many miles. And it doesn't matter how many. Okay, so that's kind of where we're at. And if we were to label our axes here, we would have number of miles and then our cost. Okay. Last one. Elizabeth wants to buy 2 types of cookies for her staff holiday party. Each package of red velvet cookies costs $3, and each package of sugar cookies costs $2. Elizabeth has $18 to spend on the cookies. So we are going to say that X is the number of red velvet cookies, or packages of cookies. And I'm not sure why this keeps doing that. We're going to say that Y is the number of sugar cookies, or packages of sugar cookies. So when we go ahead to solve this, if each package of red velvet is $3, we're going to do 3x. And each package of sugar cookies is $2, we're going to have 2y. And that's going to equal the total amount, which is 18. And we're changing colors again. Once we have that, we're going to go ahead and graph that. So think back to cover up. If I cover up my y, I get 3x equals 18. And I divide it to get x equals 6. And I cover up my x, I get 2y equals 18. So if I divide, I get y equals 9. So I can go ahead and graph those 2 points. Sorry. And then draw a line to connect them. When I draw my line, I'm not going to go beyond those because I can't have 0 I can't have a negative number of packages, so really my line just goes from here to here. Okay, and then this is going to be the number of sugar cookies versus the number of red velvet. Sorry, the other way around. Number of red velvet and the number of sugar. Okay, and that's it. I want you to go ahead and try the last one on your own, and then we can go through it. One thing I want you to be careful of is I'm going to tell you that this is in standard form, so you're going to have ax plus by equals c. You're going to use slope-intercept form when it tells you a rate that something's changing, and then there's some questions to answer there. So go ahead and do that, have it checked. When you're finished, let us know, and we will kind of make sure you're on the right track before you try your practice. And that's it for this unit. Have a great day.